if this is the Earth's surface, from the Earth's surface up till 11 kilometers approximately. Okay, this layer is called as troposphere. Now, where does the troposphere stop? It stops at a thin level called as tropopause. Pause means stop. Correct. Above troposphere, from troposphere to 50 kilometers height, the layer is called as stratosphere. Correct. From stratosphere up till 80 kilometers. Okay, 50 to 80 kilometers. This is 50 kilometers, correct? 50 to 80 kilometers. It is called as mesosphere. Correct. From mesosphere up till 700 kilometers, it is called as thermosphere. Okay. Beyond 700 kilometers, it is called as exosphere. Okay. At around 60, 75 to okay, around from 60 kilometers upwards till 125 kilometers. Correct. This layer, okay, is called as ionosphere. Okay, today I will give you some idea about ionosphere. You will learn in detail about ionosphere in navigation. Am I clear? Okay. Now, here, what differentiates every layer? What differentiates every layer? See, every layer has a different temperature profile. Temperature profile is the one thing that differentiate layers. Am I clear on this? Okay. Now, yesterday, according to ISA, what is the lapse rate up to 11 kilometers?
1.98 degrees Celsius per 1,000 feet.
Very good.
6.5 degrees Celsius per kilometer.
Very good. So, in the troposphere, the lapse rate is 1.98 degrees centigrade per 1,000 feet or 6.5 degrees centigrade per kilometer. Okay. Now, the place where the lapse rate becomes less than 1.98 degrees centigrade per 1,000 feet, that is the place where you see tropopause. Correct. Initially, okay, 11 to 20 kilometers, the temperature is constant at minus 56.5 degrees centigrade. Correct. Thereafter, the temperature rises by how much?
1 degree Celsius per kilometer or 0.3 degrees Celsius per 1,000 feet, I think.
Perfect. Okay. So, in the stratosphere, as you go up, the temperature rises. Can someone say why? Yesterday, I have given you a hint. I did not teach you, but yesterday I have given you.
Because of ozone layer.
Very good. Perfect. Perfect. See, at around 25 kilometers, 20 to 25 kilometers, you see ozone layer, correct? Yesterday, I told ozone layer is a greenhouse gas. That means it will absorb heat and keep it. Correct. So that is the reason for increase in temperature in the stratosphere. How many of you understood this? Correct. Next, mesosphere. Again, after stratosphere, what is the layer that differentiates stratosphere and mesosphere? Because that layer which differentiates troposphere and stratosphere is tropopause. Pause to troposphere. Now tell me, what is this layer?
Stratopause.
Very good. It is called as stratopause. Clear? Okay. Now, again in the mesosphere, as you go up, temperature falls. Mesosphere has a specialty. It is the coldest layer in the atmosphere. Coldest. It is the coldest layer. Temperatures range from -80 to -100 degrees centigrade. Am I making sense? Okay. Now, do you see when the rockets are entering the Earth, when the rockets are entering their surface, like they turn to burn when they are coming through the outer space? Have you seen this in the movies, etc.? Okay. Have you seen the movie Gravity? I think you guys have to watch the movie Gravity. It's a beautiful movie. Okay. Now, because of the layer thermosphere. See, in the thermosphere, the atoms are very hot. I don't know the exact reason. Probably they are closest to the sun. That's why the atoms are hot. So it is the hottest layer. I mean, see, I'll tell you what to write down. Don't write down. See, every atom is at a very high temperature. Every atom is at very high temperature. Okay. Now, I'll give you an example. You tell me. There is a cup of tea. Okay. Next, there is a bathtub. Now, let's say this cup of tea became cold. It is at room temperature 26 degrees centigrade. This bathtub water is also at 26 degrees centigrade. Okay. Now, if you give heat, let's say 10 joules, 26 degrees centigrade cup of tea will become 60 degrees centigrade and you can have it. Clear? But if you give 10 joules to bathtub, will it become 60 degrees centigrade? No, because there is a lot of water in the bathtub. Nah, it is not sufficient. It will just become 26.5 degrees centigrade. That's all. Correct? That is the reason in the thermosphere, even though every atom is at very high temperature, the overall heat is nothing but the energy. Correct? Energy of all molecules together is called heat. So the heat of the thermosphere is very less. The total heat of the thermosphere is very less, but every molecule is at very high temperature. How many of you understood the thing? Correct? Very good. So each atom, each molecule is at very high temperature, but write down overall temperature of, or not overall, I'll write as, but total temperature, sorry, total heat content of thermosphere is less. Am I clear? So these can be the questions. These, whatever I spoke, each line is a question. Am I clear? Now, sir, you are not teaching about ionosphere. I'll tell you the reason. Because everybody of you will be attending navigation with me, mostly. Wait. Okay. Do you see how much I'll teach about the ionosphere? D layer, E layer, F layer, F1 layer. What is the height of this ionosphere? Why is it important? How will this help in radio communications, etc., etc., etc. Okay. This is the detail in which we will be studying about ionosphere, but not in today's class, but in navigation class. Clear? Next. Just note down ionosphere is important for HF communication, high frequency radio communication. In brackets, you write down long distance radio. Am I clear on this? Now, I'll teach you in detail about every layer. Okay. Here, by definition, troposphere means where the lapse rate is 1.98 degrees centigrade per 1000 feet or 6.5 degrees centigrade per 1 kilometer. Is it clear? Next, here see. Height of tropopause, average height. How much?
11 kilometers.
11 kilometers. 11 kilometers will correspond to what is the distance in feet?
36,000.
Yes, 36,000 feet. Okay. Most of the aircrafts fly within this layer. Okay. Now, yesterday I have told you a sentence about water vapor. Is there any water vapor at 36,000 feet?
Yes.
Hmm.
No.
Oh, because if S is not the answer, no is the only answer. Na? See, I told you yesterday, at poles and above 30,000 feet, the water vapor is negligible. Correct?
So you asked if it's still there. It's still there. No? It's negligible.
Negligible, negligible. Okay. Neglect it. Okay, fine. Okay. So that means 99% of the water vapor on Earth is within tropopause, because beyond tropopause it is beyond 30,000 feet. So it is almost negligible, like 1% or less. Am I clear on this? Okay. And 75% of the atmosphere by mass is confined within the troposphere. Okay. These 2 points are important. 75% and 99% of water. They may ask in your exam. Okay. Now I will teach you the topics. Let's say this is Earth. This is your North Pole. This is your South Pole. Let's say this is your equator. Okay, equator on the backside of the Earth, I represented by dots. 3D structure. Clear? Now, I have told average height of this troposphere is how much? 11 kilometers. Correct? So the troposphere should be like this. Let's say this is 11 kilometers. Do you understand? Okay. Let's say, see, sun is generally here. It will give direct sunlight to equator, very slant rays to poles. That's why poles are cold. Am I clear? Next. Let's see, the molecules here are getting heated so much due to Earth. Correct? What happens? They expand. Okay, and that is the reason why the tropopause at the equator is very high. Okay, the tropopause at the equator is at around 16 to 18 kilometers. Am I clear on this? Now, same way, what happens to the air molecules at the poles?
They contract.
They contract. They are closer to each other. Correct? So that is the reason the height of tropopause at the poles is less. It's only Sorry, 8 to 10 kilometers. Clear? Do you understand the reason why height of the tropopause at the equator is increasing? Do you see? At the equator it is high. Okay. At the poles it is less. So here it is less, at the equator it is high. This is how the the tropopause is there around the this thing. Excuse me. Sorry. That is the reason. See, write the sentences. At equator, height of tropopause is equals to 16 to 18 kilometers. At poles, height of tropopause is equals to 8 to 10 kilometers. Now, average height of tropopause. How much? What is the average height of tropopause?
11 kilometers.
11 kilometers. Now you understand how it is 11 kilometers and why did I say average height, average height. Clear? Guess the height of tropopause in India. Tell me, India is close to the poles or close to the equator?
Equator.
Equator, correct? Somewhere India is here. Okay, so average height is around 16 to 16.5 kilometers. Everything is a question. Okay, they will not ask guess, they will ask height of tropopause over India. Am I clear on this? Okay, now see, till now whatever I taught you, it is very easy to understand, but from here it is difficult to understand, so pay attention. What is the definition of troposphere? How is troposphere defined? Troposphere is a layer where complete it's
Temperature falls with height.
yeah, by how much? Where the lapse rate is
1.98 degrees Celsius per 1,000 feet.
or
6.5 degrees Celsius per kilometer.
6.5 degrees centigrade per kilometer. Correct. That means, see, per kilometer lapse rate is same, whether it is at poles or at equator. Okay. Now, on the surface of Earth, if you are standing, where is it hot? Is it at the equator or is it at poles?
Equator.
Correct. So it is hot at the equator. Okay. So on the surface of Earth, it is hot at equator. Okay. Now, on the surface of Earth, it is cold at poles. Can I write this? Are these two sentences correct? Okay. Now, yeah. See, let's say at the equator, temperature is 35 degrees centigrade. Okay, I'm taking a rough. At the poles, the temperature is, let's say, 10 degrees centigrade, average. Okay, all the pole area, or let's say 5 degrees centigrade. Okay, so 35 at equator and 5 at poles. Now, what is the temperature at tropopause if you calculate the lapse rate? 5 minus 6.5 into approximately 8. How much? 8 5s are 40. 6 are 48. 48 plus 5, 43 around. How much is it? Here, how much here? Nobody has a calculator. 5 minus brackets open 6.5 into 8 brackets close. Here it's approximately it's
57.
minus 47 degrees centigrade.
Yes, sir.
Okay. Okay. According to our textbook, it is not minus 47. It is minus 40 degrees centigrade. Correct. Now, note down the temperature of Tropopause at poles is equals to minus 40 degrees centigrade. Correct. Taking 18 kilometers at the equator, what is the temperature? 35 degrees centigrade minus 6.5. You are going 18 kilometers up, correct? Into 18. How much? 35 minus brackets open 6.5 into 18 brackets close. Here it will be minus 82 degrees centigrade. If you calculate this is equals to minus 82 degrees centigrade. But according to our book, it is not minus 82. It is minus 80 degrees centigrade. Am I clear? Can I write the temperature of Tropopause at equator is equals to minus 80 degrees centigrade. See, I did not discover anything. Just I know the definition of Tropopause, that lapse rate is 1.98 degrees centigrade per 1000 feet or 6.5 degrees centigrade per kilometer. Using that, I have calculated and I approximated 42 or 43. I approximated to minus 40. Okay, 82 I have approximated to, sorry, minus 82 I have approximated to minus 80. That is what mentioned in the textbook. Okay, minus 80. I am just teaching you how it is minus 80. Am I clear? Now, if I say this statement, say true or false. Here, at the surface of Earth, equator is hot. But at the tropopause, equator is colder. Do you see at the tropopause of the equator, it is colder. Tropopause is nothing but the place where the troposphere stops. Correct? This line is the tropopause. At the equator, it is hot at the surface, it is cold at the poles. But at the tropopause, it is minus 40. That means it is hotter because at the equator it is minus 80, which is colder. How many of you understood the temperature profiles? Am I clear? So note down the statement. Equator is hot at the surface of Earth, but it is colder at the tropopause, and vice versa. Vice versa means opposite, correct? If you take poles, it is colder at the surface of the Earth, but at the tropopause it will be hotter. Raise your hands if you guys understood everything what has been taught till now. No, you guys did not understand. Sujita?
Can you please explain this again?
Huh?
Can you please explain this again? It's a proper pause.
Okay. Fine. I'll explain at the end of the class. Okay, so I'll go to next layer. You keep thinking of this also. Once I explain everything, you will understand. Okay. Now this is about the height of the tropopause. This is about the temperature at the tropopause. Clear? Sujita? Yeah, guys, do you mind? Yeah, her mother tongue is Telugu. I'll explain it in Telugu. Okay, if your mother
No,
tongue
sir,
is
it's
Hindi.
okay, sir. No, sir, it's okay.
Huh?
No, it's okay. You explain in English only, sir.
Okay, fine. See, you know, the sun's rays are falling directly on the equator. But if you take poles, they are falling very slantly, correct? See, morning, the sun's rays are falling slantly on your house, so morning it is colder. But in the afternoon, sun's rays are directly falling on you, so that's why it is hotter in the afternoon. Correct? In the afternoon, sun's rays are falling directly, that's why it is hotter. Now tell me, at the equator, is it at the surface of Earth at the equator, is it colder or hotter?
Hotter, sir.
At the poles,
It's cold.
it's cold. So because equator is hot, the Earth is hot, the molecules will expand. Correct. So that is the reason at the equator, tropopause extends to 16 to 18 kilometers. It is not a perfect circle as I draw first diagram, but it is expanded at the equator. Okay. Now, because the temperature at the poles is cold, is less, now they have contracted. The molecules have contracted. They are close to each other. Correct. Now, that is the reason the height of tropopause at the poles is only 8 to 10 kilometers. That is why average height of the tropopause is 11 kilometers. Somewhere we took average between 16 to 18 and 10 to 8 to 10. So it is 11 kilometers. That is what you understood about the height of the tropopause. Correct. Now, when you take about the temperature profile of the tropopause, correct. So if you believe 3.5 is the average temperature, 35 degrees centigrade is the average temperature. Now, as you go up for every kilometer, the temperature is decreasing by 6.5 degrees centigrade. Now, how many kilometers you are going? Because it is a height of 18 kilometers, you are going 18 kilometers. So it is at the equator, the tropopause temperature is minus 80 degrees centigrade. Okay. Now, at the poles, imagine it is only 5 degrees centigrade, very cold. Okay. Now, if you go up 8 kilometers, okay, so for every kilometer it is 6.5 degrees. Okay, so that will be around minus 40 degrees centigrade. Understand? So now, Sujita, tell me, minus 80 is colder or minus 40 is colder?
Minus 80.
Correct. So that means, see, at the tropopause, equator is colder than at the poles. Correct. Those are the two sentences I have written down. Okay, that is the one sentence. Equator is hot at the surface, but at the tropopause it is colder, and vice versa. Vice versa means poles are colder at the surface, 5 degrees centigrade, but at the tropopause it is a bit hotter when compared to the tropopause at the equator. All these statements are perfectly understood, everyone.
Yes.
Okay, I'll move on. What is the most important gas for weather? Weather means formation of clouds, rain, etc., etc., etc. Options:
Water vapor.
nitrogen, B, oxygen, C, water vapor.
Water
Water
vapor.
vapor.
Water vapor, because clouds are nothing but water vapor. Correct. Now, is there any water vapor beyond 30,000 feet?
No, sir.
Negligible, sir.
Negligible. Okay, no or negligible. Correct. So that is the reason there is no weather or cloud formations beyond tropopause. Or you can write all weather is confined to troposphere. This is a correct statement. How many of you understood this statement? Correct. Next. Okay. not the jet streams topic. Hmm. Just give me a second. Okay. Do you see? Okay. So now all the weather will happen. So this is the tropopause. This is the tropopause. Okay. All the weather will happen below the tropopause only. Okay. Now, just below the tropopause, there are something called as jet streams. These are called as jet streams. So what is a jet stream? I'll explain. Here, jet streams are fast moving air around the earth. Okay. So for example, if you take wind, okay, do you see the fast moving air? This, okay, see the like if you, okay, if you increase the flight level to 340, okay, do you see a perfect pattern which is moving, meandering winds like waves? Okay, now see the speed with which they are moving. They are moving at 85 knots. Here the speed is 131 knots. Okay, a Cessna cannot take off at in a wind of 17 knots, in a crosswind of 17 knots. Do you see high fast moving winds? These are called jet streams. There is one whole chapter where we discuss jet streams in detail, why they are happening, how is it important for India. Correct, we are getting rains only due to jet streams. I'll explain why at the next chapters. Okay, our monsoon is happening due to jet streams. Okay, how these winds will come and cause rain in India, I'll explain it in that chapter. But you have to understand these jet streams now, okay, they will form just under the tropopause, and why it is like I'll explain in the 13th or 14th chapter. Okay, just remember, jet streams will form just under the tropopause. What are jet streams? Fast and I mean very fast meandering winds that will happen all around the surface of the earth. You see, this is the jet stream. It will go around the surface of the earth, and it will see, this is this cross section. Am I clear? So this is the jet stream. This one. This is the jet stream. Okay, this is called a subtropical jet stream. This is polar jet stream. Okay, this is Arctic jet stream. We will discuss in detail. Am I clear on this? So, question: where does jet stream occur? Just below the tropopause. Correct. So, note that point: jet streams occur just below the tropopause. Now, in that just below the tropopause, where do they occur? They occur at -40 and -60. Yeah. Okay. So jet streams occur just below the tropopause. I'll explain this. There is one whole day which I dedicate why they are occurring just below the tropopause. When I explain, I'll explain. Clear? Next. Here at -40 degrees north and south, and at -60 degrees north and south, there is a break in the tropopause. The tropopause. Okay, these breaks are formed due to jet streams. Okay, I'll show it like here. Okay, no, not here. I'll show it here. Do you see this layer is tropopause? This is the tropopause, but see it is broke here at minus 40 degrees north. It is also broke here. There's a step. Understood? That break is at minus 40 and minus 60 degrees north and south. Both it happens in northern hemisphere and southern hemisphere. Minus 40 degrees south, minus 60 degrees south. Am I clear on this? That is called as breaks in the tropopause. Okay, at these breaks, the jet streams occur. Here. Have you noted this down? Correct. Now, here, see what happens when you enter a jet stream with your aircraft. Have you remembered, like last year, one Air India aircraft entered a jet stream suddenly and full turbulence, correct? Because suddenly you are going, let's say this is the jet stream. Okay, let's say this is the jet stream. Now you have seen at the jet stream, the speed is minus 120 nautical knots. This is the speed of the wind. Correct? Sorry, not minus, it is 120 knots. Now, if you're flying like this, okay, at 36,000 feet, where there is no jet stream, the speed of air is maximum 10 knots. Suddenly, when you enter a jet stream, you enter from 10 to 120. So your aircraft will be violently thrown like this to the right. But see, the pilot has entered because jet stream is a pure air without cloud. Okay, you cannot see a jet stream. Correct? It is clear. Your airborne weather radar cannot capture jet streams. Correct? So that's why the turbulence due to jet streams is called as CAT. Clear air turbulence. I'll also discuss clear air turbulence in further classes in detail. So clear air turbulence occurs at the tropopause, in brackets, near the jet streams. Am I clear on this? Maximum height of clouds. If a cloud is extending from the ground also, what is the maximum height any cloud can extend?
11 kilometers.
11 kilometers.
11 kilometers. Or you say tropopause. Okay, maximum height a cloud can extend is tropopause. I'll show you one example. I will show you one diagram. Do you see? This is a small cumulus cloud developing. Now it became big, and do you see? At tropopause, it flattened out. It cannot extend beyond tropopause because there is tropopause. Okay, so it will restrict its extension, but there is a mechanism to it called as stability. I'll explain in that adiabatics and stability chapter why it is restricted. Okay, so this is called as anvil of the cloud, which I'll explain later. Now, coming to stratosphere. Okay, what is the height of stratosphere?
Tropopause up to 50 kilometers.
Correct. Okay. Now, initial 8 to 10 kilometers of the stratosphere. If this is Earth, this is tropopause. Okay, this is 50 kilometers. So this is stratosphere. Correct. Initial 8 to 10 kilometers. Yet the temperature is constant at the rate of minus 56.5 degrees centigrade. Correct. From there, the temperature keeps on increasing. Now, here, tell me, you know how to define troposphere. Define troposphere, everyone. Define troposphere. The layer in which
The temperature decreased with height and the lapse rate is 1.98 degrees Celsius per 1,000 feet or 6.5 degrees Celsius per kilometer.
okay. Now define tropopause. This is the definition for troposphere, correct? Define tropopause. I did not teach you this. I forgot. I'll teach you. Here, practically speaking, okay, the temperature will not decrease by 1.98 degrees centigrade per kilometer. That means your temperature will start decreasing, but around 1 degree centigrade, and it will stabilize. It will become zero. Lapse rate will become zero at the tropopause. Clear? So that level where the temperature stops decreasing at 1.98 degrees centigrade per kilometer is called tropopause. That is the reason first 8 to 10 kilometers, the temperature is said to be constant at minus 56.5 degrees centigrade in the stratosphere. Am I clear? Next. Here, why is tropopause the temperature is increasing? Because of
Ozone layer.
what is the height of ozone layer?
20 to 25.
25.
Maximum concentration 20
Yeah.
to 25 kilometers.
Yeah, maximum concentration of the ozone is at 20 to 25 kilometers. That's a very important question here. Okay, next. Here,
Excuse me, sir.
yes,
Can you repeat the definition of tropopause?
the layer or the level where the lapse rate is less than 1.98 degrees centigrade per 1,000 feet. Okay, see, this definition is given in Oxford. Okay, but actually speaking, tropopause is the layer where troposphere ends. Next. Okay, all weather happens in only troposphere, correct? Now let's take, this is a bowl, this is a flat surface, this is a bowl. Bowl means a small ball like this. If you drop a ball in the bowl, what happens to the ball? Ball will come here, come
Yes.
here, come here, come here, and stop here in the center. If you invert a ball like this, and if you drop a ball, what happens to the ball?
Fall down.
Ball will fall down and it will go away. It will never come back, no? Correct. Imagine a ball is here, you displace it like this from here. Again, it will come back to the center. But here, if you once you push it, it is gone forever. Clear? Here, I'll explain. This is called as stability. I'll explain. Atmosphere is also at some places it is stable, at some places it is unstable. But I will just give you an idea today. I'll explain everything in next chapter. Okay, these are the basics. Now, if you take this as Earth, this is Tropopause, this is Troposphere, this is Stratosphere. Correct. Now, in the Tropopause, okay, take a parcel of air with some water vapor in it. Now, what happens if it goes up? This parcel of air, will it become colder or hotter? Colder. Correct, because in the tropopause the lapse rate is positive. That means the temperature is decreasing. When it becomes colder, the water vapor will attach, okay, will condense with other water vapor molecules, and it will form liquid water droplets. That is nothing but your cloud. Cloud is nothing but small water droplets together. Clear? That means cloud will form here. There is formation of clouds in the troposphere. That is possible. But see, if you take a parcel of air where there is water vapor also, and if you take it above the tropopause, will the temperature decrease? In the stratosphere, will the temperature decrease?
No.
No. So will these water vapor molecules ever condense to form water droplets?
No, sir.
No. So clouds or weather or rain does not occur in the stratosphere. Correct. So only in the troposphere rain happens. Here, this kind of atmosphere where it is suddenly the wind is going up when it is causing rain. Here, this is called as unstableness. The atmosphere is considered unstable in the troposphere. That is why we are getting rains. That is why the air is going up and it is causing rains. Okay, this is not the complete explanation, but I'll give the complete explanation in the next chapter, in like the other chapter where I discuss stability. But you have to understand that troposphere is unstable. Now, is the stratosphere unstable?
That's stable.
It is stable. Correct? It is stable. That means even if you take a parcel of air up, it is never going to form a cloud. Okay, so it is stable. So stratosphere is stable and troposphere is unstable. Super duper clear, everyone? Okay. So the rise in temperature with height is called inversion. Okay. See, normally what happens is from the ground, if you go up, the temperature should decrease. That is the normal atmosphere. If it behaves like as you go up, the temperature increases. It is called as inversion. Clear? Okay. Inversion happens in the stratosphere. Simple. Because in the stratosphere, as you go up, instead of decreasing temperature, the temperature keeps increasing. Clear? So that is the word, that is the meaning of the word inversion, which again I'll explain in detail in the future chapters. Where is that word? The temperature, rise in temperature with height is called inversion. So this region is stable. You understood the word stable? You understood the word inversion? Okay, any other doubts in this two words? No. Okay. Now, here, almost negligible, beyond 30,000 feet, correct? So as Sanisha said, it is negligible, but still 1% is there. Correct, Sanisha? So that sometimes will lead to formation of clouds in the stratosphere also. Those clouds are called as nacreous clouds or mother of pearl clouds. It looks like the light diffusing from a pearl. Correct? From a pearl, light will become like 7 colors. Correct? It looks like pearly. Okay. It is seen in the winters at high latitudes. That means at close to the poles, those people only can see these clouds. We living at tropical areas, we cannot see these clouds. Okay. It is seen only at the poles in winters at higher latitudes. Okay. So what are the clouds in the stratosphere?
Nacreous cloud or mother of pearl clouds.
Nacreous clouds or mother of pearl clouds. Here, this question was asked when I gave my exam. I remember them asking this question when I gave my exam. Now, upper boundary of stratosphere is called?
Stratopause.
Lower boundary of stratosphere is called?
Tropopause.
Very good. Okay. So that completes troposphere. The most important question is this: nacreous clouds. Second most important question is stable. Third most question is height of ozone layer. 20 to 25. Without, yeah, I guarantee in these three questions, now, when you're giving exam, you will see one question in your exam. Clear? Shall I move on to the next layer? What is next layer?
Mesosphere.
Mesosphere. So the lower boundary of mesosphere is
Stratopause.
Stratopause. The height of the mesosphere is from 50 to
Stratopause to 80 kilometer.
yeah, from 50 to 80 kilometers, because Tropopause is ending at 50 kilometers. Sorry, Stratopause is at 50 kilometers. Stratosphere ends at 50. So 50 to 80 is the mesosphere. And it is the coldest layer, and the temperature is, I mean, again, the temperature, because the ozone layer is over, as you go up, the temperature falls. Correct? It is the coldest layer, minus 80 to minus 100 degrees centigrade. Okay. Now, here, can you tell me what is happening in this picture? Can you tell me what is happening in this picture? Can someone describe the beautiful scenery? Use logic.
There's a construction going on.
Okay, construction going on.
It's night. Night is about to come.
Very good. No. It is already night. I'll tell you why. See.
Twilight.
No. See, do you see any people here? It is absolute night. Don't you think? See the sky also on the top. It is full night. Correct. This is not sunshine. Okay, this is night. But do you see the clouds here? Okay, I'll tell
Yes.
you why you see the clouds there. Okay, I'll give you the explanation. If you take this as Earth, okay, now let's say this is the place. Okay, now let's say if the sun is here, okay, I'll take Earth as like this. Okay, if you are standing here, what time is it? Is it afternoon or morning, night?
Sir, afternoon.
No.
Because sun's rays are falling directly on your head. Now, at your eye level, if the sun is here, what is it?
Sun.
Is sunset, correct?
Yes,
Yes.
sir.
Okay, so sun has risen here. Okay, noon, and then sun is setting now. Okay, now when the sun is here, you cannot see sun. That means this part of the world will be night. Clear? Now,
Yes, sir.
let's say sun went here. Okay, so this is the earth. This is the earth, correct? So this part of the earth is having noon. Okay, this part of the earth is having good morning. They are just seeing the sun. Is this understood? Okay, but if you are standing here, see the 11 kilometers is troposphere. Next up till 80 kilometers is stratosphere. Sorry, 50 kilometers is stratosphere, and 80 kilometers, this is mesosphere. Correct. So when the sun is here, see, for you it is night because the sun's rays are not able to penetrate the earth. But see, they can sunshine. The sunshine can happen with these clouds, and the clouds can reflect the light from there. That means even though it is night, you can still see the clouds. Correct or not? But you see, if they are in stratosphere, if the clouds are in stratosphere, see, you cannot see the clouds in the stratosphere because again, earth curve will not allow the light to light them. So the criteria to see is the cloud should be very high. That is in the mesosphere. Understood? Understood. That's why the clouds in the mesosphere are called as noctilucent clouds. Noctilucent clouds. That nocti means night. Lucent means visible. How many of you understood the logic? Raise your hands here. You're busy writing.
Sir, can you please repeat?
Yes, I can repeat. Let's assume this is Earth. Okay. If you are standing here on Earth, if the sun is here, it is sunset. Correct? Sun is going down. This though understood, Manshi?
Yes.
Now, if the sun is here, the sun's rays cannot fall on you directly because the earth is obstructing it. Because the curvature of the earth is obstructing.
Yes, sir.
That's why we call it as night. Okay. Now, let's imagine the sun is here. Correct. Now, let's say this is troposphere, this is stratosphere, this is mesosphere, and there are some water vapor or clouds in the mesosphere. And in the stratosphere, there are clouds. Correct. See, now I'm telling you, here is the sun. Correct. Now, can the sun's rays reach directly you? It will not.
Also.
Okay. Can sun's rays reach the cloud in the stratosphere? No, correct, because the curvature of the earth will obstruct the sunlight. Correct. But see, the sun's rays can reach
Mesosphere.
mesosphere. And now, if there are any clouds in the mesosphere, they will be visible only in the night. Correct. That's why the clouds of mesosphere are called as noctilucent clouds. Nocti means night. Lucency means visible. They are visible only in the night. That's why the name is given noctilucent clouds. Am I clear on this?
Got it, sir.
Okay, very good. So noctilucent clouds occur in mesosphere. I want you to understand what is meant by noctilucent. That means they are visible only in the night, and this is the reason. Do you see? The clouds are visible. It is absolute night. It is dark above you and below you. If you are standing here, it is very dark, but still you can see the clouds because there somewhere the sunset has happened, but that clouds are getting illuminated, and that light is falling, is being reflected from very high clouds in the mesosphere. How many of you understood this logic? Okay, these clouds are. The upper boundary of mesosphere is called as
Mesopause.
Tropopause. Clear? That completes mesosphere. So ionosphere, here according to your textbook, it is 60 kilometers, but the same Oxford gives in navigation ionosphere from 75 to 125 kilometers. Sorry, 225 kilometers. Okay, D layer, E layer, and F layer. Okay, so if you get ionosphere is at 60 kilometers in meteorology exam, that is a correct option. Okay, because see, knowledge is different, passing exams is completely different. We'll prepare for both. Next, ionosphere is important for radio wave propagation. Which wave propagation? Which radio wave? Which radio
Radio
wave?
wave.
High frequency.
H of wave, H of radio, or distant communications, long distance radio, long distance radio. And the last layer, thermosphere, it extends from mesopause to about 700 kilometers. Beyond 700 kilometers, it is called exosphere. Okay. Now tell me, yeah, in the starting, I taught you a sentence. What is that sentence? Earth atmosphere is 480 kilometers thick. How come thermosphere is at 700 kilometers? So in one book, they give contradictions, but we cannot do anything because here it is there in the exam. They will ask what is the thickness of Earth atmosphere. You have to answer 480 kilometers thick. That you have to remember. See, if there is a mistake and they are going to carry it forward in the exam, we are going to learn it as a mistake. Okay, we will learn it. Okay, but what is the height of the thermosphere? Answer please.
700 kilometers.
700 kilometers. Correct. Now it is a very thin and air molecules are very far away, but each air molecule is at very high temperature. Okay, the air is very thin and the temperature of air molecules are very high, but they are far apart from each other. So the total heat present in this layer is very less. So total heat is less, but temperature is very high. I think I have explained with an example of water bath and a teacup. Here, that's it. No more questions from this atmosphere. Okay. Now, see, I'll share the notes for first chapter in class. Okay. See, I'm editing the notes a bit. Okay. I'll share only first chapter today. Okay. Now, after class, I want you to go to IC Joshi. Okay. Someone created this PDF and shared in my group. Okay, if you want, I'll share it for you also. But I don't like, see, because IC Joshi has struggled a lot to make this thing correct. So don't Xerox a PDF or something, because I cannot show to my book. See, I have also bought IC Joshi. Correct. I suggest always to respect the authors. They have put in their hard work. Buy an IC Joshi. Okay. So in your IC Joshi, there are questions. Okay. Solve them today itself. That is the homework. Okay. And put it in the group. I have to understand that you have solved them. Am I clear? Am I clear on this?
Yes, sir.
Okay. And that's it. First chapter is over. Here.